Alright, in this lesson we're going to be adding and subtracting polynomials. Alright, so if we have two binomials, 5a plus 6 plus the quantity 7a plus minus 3. Alright, so let's be very careful for this plus sign here. Okay, this is like distributing a positive 1 through, which does nothing to the second term. So I could rewrite this without my parentheses. So I have 5a plus 6 plus 7a minus 3. I've seen some techniques if you wish to rewrite them all in order, 5 or next to each other, like terms. 5a plus 7a are both like terms. They both have a variable a, and then plus 6 minus 3 are also like terms. They both are just numbers without any variables. All right. So 5a plus 6 are terms without variables. 5a plus 7a is 12a. Okay, just add your like terms. Add your coefficients. Keep your variable. Plus 6 minus 3, which I get plus 3. So if you add these, you get 12a plus 3. Okay, so nice and easy. Let's start with the next one. So here we have trinomial minus a trinomial. So we have 5x squared plus 3x minus 7 minus, so let's be careful here. Okay, here's our big Q. Minus 2x squared minus 6x plus 5. Alright, so in this case, I need to distribute this negative 1 or this minus sign to each term inside these parentheses. So the first parentheses has nothing but a positive 1 here in the front, so these parentheses can just drop. So I have 5x squared plus 3x minus 7, and distributing this negative 1 is minus 2x squared plus 6x minus 5. Okay, so let's be very careful with this negative 1 here, or negative sign in between before my parentheses. Okay, so just distribute. So now I'm going to combine my like terms. I have 5x squared minus 2x squared. Here I have 3x squared. Okay, like terms both have the x and the square. Okay, so they have to have the same variable and the same exponent. And then you can add and subtract the coefficients in the front. All right, next one is positive 3x and positive 9x, and positive 6x, which gives me a positive 9x. And our last one here is negative 7 and negative 5, which gives me a negative 12. So simplified is 3x squared plus 9x minus 12. Next example here, 7x squared y plus 6x squared y minus 3x squared y plus 4xy squared. I'm sorry, the second term was 6xy squared. Okay, so this one's a little bit more confusing because everything has an x and y, but the like terms are the ones that have exactly the same base and exponents. So 7x squared y. What else has an x squared y? This next term here, it has an xy squared, so it's not the same. The following term has an x squared y, so this term and this term are the same because they both have the same bases with exponents. X squared y, x squared y. So I have 7x squared y minus 3x squared y. Okay, those are my like terms. The other terms is 6xy squared, 4xy squared. So this is a positive 6xy squared plus 4xy squared. Now these are like terms because they both have xy squared as their variables. Okay, and then just go back and subtract or add the coefficients. So 7 minus 3, so I have 4x squared y plus, here I have 6 and 4, 10xy squared. Let's take a look at a few more examples. 12a cubed plus 5b squared plus 2 minus 12a squared plus 8b squared plus 2a. Alright, so again, one of the biggest things we're going to look out for again is the minus sign in front of my parentheses. Alright, so let's be careful. So in this case, this has a positive 1 in the front, so I could just drop these. So I have 12a cubed plus 5b squared plus 2 minus 12a squared minus 8b squared minus 2a. Alright, so I'm looking at my first term here. I have 12a cubed. Is there another term here that has a 12a cubed? If you go down the list, no other term has a 12a cubed. You have an a squared and you have just an a, but none of them have an a cubed. So this is not a like term. This does not have like terms with anybody else. So we're just going to simply just jot down 12a cubed. There's nothing else I could do with that term. My next term here is 5b squared. Do I have another term with a b squared? Well, in this case I do. Here's my negative 8b squared. So these two are like terms. So I have positive 5 minus 8b squared. So I have negative or minus 3b squared. Here I have a positive 2. Do I have any other terms that just have a number without any variables? I do not. So I'm just going to say okay. Plus 2 here. Minus 12a squared. Again, I don't have any other terms with a minus 12a with an a squared, so minus 12a squared. And again, and minus 2a, and there's no other terms with the minus 2a. So there's not much I could do in this one. You can rewrite this so the exponents are from least to greatest if you want to. So this would look a little nicer if it's 12a cubed minus 3b squared, if so, minus 12a squared. And again, you can flip-flop those. They both have a square. Minus 2a plus 2. Alright, so there's not much simplifying you can do here. Again, they have to have the same base and exponent. So be careful for those. Alright, let's take a look at one more. It says write an algebraic expression for the shaded area. Alright, so I have a shaded area here in the gray area, and I want to write an expression for this shaded area here. Okay, I just went back and I changed the white circle to a yellow circle so you can see the difference. Okay, so the area I'm looking for is the gray shaded area here, and I want to find that an expression for this area. So pretty much what I'm looking to do is take this circle, this yellow circle, away from this shaded area here, or this other bigger circle. Alright, so I'm looking to take this yellow circle, the area of this yellow circle, away from the area of this larger circle. Alright, so if I'm looking to do so, what operation should I be thinking? If I'm looking to take this away, we should be thinking here at this point we're looking for subtraction. Alright, so I need the area of the big circle, and I need to take away the area of the small circle. Okay, so just to recall, area of a circle, area equals pi r squared. My radius of my big circle, so for my big circle, the radius is r is equal to x. For my small circle, r is equal to 1/2 x. Okay, because it's the x in this case represents the diameter, so half the diameter will be the radius, so half of the x. Alright, so the area of the big circle is just going to be pi, plugging in x for r, pi x squared, or simply pi x squared in this case. Here it's going to be pi 1/2 x squared. So in this case I'm going to have pi times 1/4 x squared. So my last step here will be, since I'm looking for the area of the shaded region, so the total area here is going to be pi x squared minus 1/4 pi x squared. Question becomes, am I done? Am I simplified? Did I simplify this all the way? Well, they both have a coefficient of pi, or 1/4 pi, and they both have an x and an x squared. So you could actually simplify this one more time. So this is actually 1 pi x squared minus 1/4 pi x squared. So 1 minus 1/4 is actually 3/4 pi x squared. So the area of the shaded region is area equals 3/4 pi x squared units squared.